The sky's electric curtain. Imagine the sky suddenly decides to throw a neon rave without inviting anyone. This isn't magic or a glitch in the simulation, it's the Aurora Borealis. But what is actually happening up there? To understand it, we must leave Earth and travel 93 million miles away to our local star. Grab your parkas, because the story begins in the fiery heart of the Sun. Our Sun is a churning ball of superheated plasma. It is constantly sneezing out a stream of charged particles known as the solar wind. It breathes life and energy into the solar system. Occasionally, the Sun wakes up and lets out a massive burp known as a coronal mass ejection, or CME. These aren't just breezes.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Tons of charged particles, mostly electrons and protons, are hurled into space. They zip through the cosmos at over 1 million miles per hour. Talk about a cosmic speeding ticket. If these particles hit Earth directly, they would strip away our atmosphere. Thankfully, Earth has a built-in security system, the magnetosphere. This invisible magnetic shield protects us day and night. The shield deflects most of the solar wind around the planet like water flowing around a rock. But no shield is perfect. Near the North and South poles, the magnetic field lines dip inward, creating funnels. The solar particles sneak in through these magnetic funnels. They crash into our upper atmosphere, slamming into gas atoms like 1 billion tiny pinballs hitting a scoreboard. And that collision releases energy as light. Here is the chemistry of the colors. When solar particles hit oxygen atoms at lower altitudes, about 60 to 150 miles up, they emit that classic, ghostly green light we see most often. But go higher, above 150 miles, and the oxygen is thinner. Here, the collisions produce a rare, blood-red glow. It's a sight that historically terrified villagers who thought the sky was bleeding. If the particles hit nitrogen atoms instead, you get beautiful blues and purples. Sometimes, you see pink fringes at the bottom of the curtains. It's a literal atmospheric chemistry set. Before science explained it, cultures had their own legends. In Finland, they call it ravontulet, or foxfires, believing a magical fox ran across the snow, sweeping sparks into the sky with its tail. The Vikings believed the lights were the reflections of the Valkyries' armor as they led fallen warriors to Valhalla. Others saw them as spirits of the ancestors dancing. While the North gets the Borealis, the South Pole has its own twin sister, the Aurora Australis. The symmetrical light shows often happen at both ends of the world simultaneously. It's a reminder that we live inside the atmosphere of a very active star. So, if you could pick any color for the sky to turn tonight, which one would it be? Let us know in the comments below.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.